Alright, in the last two videos we looked at solving equations with one step and with multiple steps, but in both cases there was only a single variable on one side of the equation. So now we're going to extend our problem solving to include variables on both sides of the equation. And in truth it does not make the problem very much harder. We just have to remember the one key step here, which is to get all the variables together on one side. So we want to get like terms together on one side. There's no new vocabulary in this section, just problem solving tips and some examples. The first thing to do, same as last section, is clear parentheses by distributing, and with this I'll say simplify each side. Okay, so if one or other side, left or right hand side of the equation, could be simplified, you want to simplify that side first, and part of simplifying it is by clearing parentheses by distributing. So simplify each side. Alright, once you've simplified each side as much as possible, distributed, cleared parentheses, combined like terms, you want to get all of the variable terms together on one side of the equation, and then move all of the numerical or non-variable terms over to the other side of the equation. So to do that, you're going to add or subtract the x term or the variable term over to one side or the other, and it doesn't matter if you move them to the left or to the right. Just a key reminder, notice the difference between simplifying an expression and applying the golden rule. When you're simplifying an expression, when you're doing this, you're following PEMDAS. So this says, when working on one side of the equation, follow PEMDAS. So that's here. Simplify one side of the equation, follow PEMDAS. It's just an expression when you're only looking at one side. On the other hand, once you've got both sides fully simplified, you're applying the golden rule, which means you're doing the same thing to both sides simultaneously. Okay, so that'll be an underlying theme, is always keep track. Am I simplifying an expression or am I solving an equation? Here we go. Note the three possible results. Okay, when you're solving an equation, in the past we've always had a solution, so we had one final answer. But it's also possible, in addition to having an answer, you could get no solution, or you could get all solutions, which is called an identity. So I'll show you some examples where this will happen, and we'll go from there. Alright, first example, variables on both sides. You see we have a 3x here and an 8x here, so we have variables on both sides. You might be tempted to move all the x's to the left, but just plan ahead a little bit. If we were to move this 8x over to the other side, we'd have to subtract 8x, and if we subtract 8x, we're going to end up with a negative 5x, which is kind of annoying. I don't like negative numbers myself. Whenever possible, I try to avoid them. So for me, it's better to subtract 3x, cancel those out. Now I have 3 equals 8x minus 3x is a positive 5x. Okay, the reason I like that better is because I just prefer dealing with positive variables whenever possible. Doesn't matter though, ultimately. Now we've chosen to put the x's here on the right hand side, which means we need to start solving by getting everything else away from the x's. So how do I get rid of a negative 4? Well, of course I add 4. And the golden rule says if I add 4 here, I must also add 4 here, giving me a total of 7 equals 5x. Last thing to do is the x is being multiplied by 5. To undo that, I could divide by 5. Cancel out, and we get x equals 7/5. Final answer. You're totally okay to leave it as an improper fraction. Awesome. Alright, moving on. Okay, here's another problem to do. Again, you notice we have x's on both sides of the equation, but this time the right hand side is not fully simplified. So I recommend first we distribute, and we get 3x minus 15. So we're just simplifying this side, we're not actually solving it. This side I'm going to just rewrite as the same. Alright, so here we go. What do we do first? Well, remember, it's the 4x being divided by 2, and it's also the 5 being divided by 2. So I could rewrite this as 4x over 2 and 5 over 2, but I think an easier way is this whole side is being divided by 2. So we don't like fractions, so if we multiply this entire side by 2, then the 2 in the top and the 2 in the bottom can cancel. Of course, golden rule says if we multiply that side by 2, we have to multiply this side by 2. So we can cancel this 2 with this 2, leaving behind 4x plus 5 equals. Now the 2 needs to distribute. That's why putting those parentheses were very important. It's happening to the entire side. 2 times 3x will give me a 6x minus 2 times 15 gives me 30. And now it's nice and clean. Both sides are in a kind of a simple form that I can work with. Just to mix it up, I'll subtract 6x, which will give me a negative answer here. 4x minus 6x is negative 2x. Now, instead of rewriting the plus 5 and the minus 30, you can actually do 2 steps at once. Totally okay. I know I'm going to move this plus 5 over to the other side, so why don't I just do that right now? Minus 5, minus 5. Plus 5 minus 5 cancels out. Negative 30 minus 5 is negative 35. So I moved my x's over to the left and my numbers over to the right, and I did both of those in the same step, which is okay as long as I'm showing it. I have space to show it. I cross out the things that cancel out, and I show what combines and the result. Alright, last step, we have negative 2x equals negative 35. To get x by itself, we need to divide by negative 2. Divide by negative 2, cancel out, x equals. Negative divided by negative is positive, 35 divided by 2. Again, you can leave it as a mixed number, 35 halves. Or in the case where it simplifies nicely, you might just write 17.5. Okay, let's kind of plug this back in and check and see, just to see if it's in the ballpark. So 17 is pretty close to, I don't know, 20, right? So let's plug in 20. 20 times 4 is around 80, plus 5, 85 divided by 2. This side is around, 42, something like that, roughly. And this side, if I plug in maybe around a 20, 20 minus 5 is 15. 15 times 3 is around 45. So it's very, very close. So with a very crude estimation, without using a calculator, without using decimal values or anything weird, you got something that's pretty darn close, which gives you confidence that your answer is right. If this side would have come out to be around 42, and this side would come out to be around negative 10, then you know something went wrong, and you can go back and check your work. So when you're plugging back in, you could do it exactly if you have time, but you can also just do a ballpark estimate to make sure that it's reasonable. Okay, I think, well, that's it for this section, just 2 examples. Remember to clear each side as much as possible, and then move all your variables to one side, all your numbers to the other side, and you'll be good to go.